So the idea today, Kamal, is to introduce you to our community. So I'm in charge of make some questions to you. I know that most of them are not necessary because many people really know you here, but we need to be official. And the idea is that you will explain us a little better what you have been doing. So I think it would be a nice that people know you a little better.
Hmm.
So could you tell us a little about yourself, your trajectory, and current highlight the research? Where did you come from? What are you doing, and where are you going? So if you can summarize us in few words, it'd be nice.
Okay, well, very good. Good morning, everyone. It's a pleasure to be here with you from a small city in Missouri, Rolla, Missouri, population 40,000 people. My name is Kamal Kayat. I'm a professor in the Department of Civil, Architectural, and Environmental Engineering at Missouri University of Science and Technology. Um, I'm also a director of a research center, a university-wide research center dealing with transportation infrastructure. My background is civil engineering, was undergraduate and graduate degrees from University of California at Berkeley. I spent 21 years of my career at University of Sherbrooke in Quebec, Canada, before joining Missouri S&T about 10 years ago. And in my research, I specialize in high performance concrete design and performance, mainly dealing with rheology and flow aspects of cement-based materials. I've done some of the early work in the area of self-consolidating concrete that has gained a lot of acceptance around the world because of its facility to enhance production and efficiency on job sites, reduce CO2 emission, etc. But from there, we've been doing quite a bit of work now in transportation infrastructure here in the US and before that in Canada, in collaboration with both the public and the private sectors. Try to bring technologies into applications. So you go from the lab to proof of concepts to field implementation, writing of codes, introduction of standards, and eventually employment of those technologies. Most recently, been working quite a bit on fiber composites. As you know, concrete is weak in tension. So if you try to reinforce it with various type of synthetic or metallic fibers with certain expansive agents, you can pre-stress the concrete and reduce the cracking, which is a big problem in many applications such as industrial slabs, concrete bridges, etc. All of this is really to increase the service life. So we seek also to increase the service life of concrete structures from 50 to 150 to 100 years. Also improve the sustainability of the cement and concrete industry.
Hey, this is quite a long career and a very relevant job. Looking to, I know your career well. It's a kind of guy that really goes from the science up to the applied technology. It would be nice if you could exemplify or select one of your papers that you consider as a really something outstanding in your career so people can read. And an example of applied technology that you have been involved with private or public sector. Could you do that for us?
Sure. Many papers come to mind, but probably if I would say one of the early papers, and I think that was published in the late 1990s, was a very comprehensive paper on the workability of SCC, what you call self-compactive, what we call self-consolidating concrete. That paper is highly cited, and it was published in ACI Materials Journal. But really, set the standard in terms of some of the challenges of adopting a new technology. As you know, SCC was a very innovative technology that started in the late 1980s in Japan, but in the US we were second to start working on that. And a lot of this work continued in Canada and led to really first implementation of design codes and first applications outside the lab in the 1990s. But that paper really, I think, was a milestone in getting that technology accepted in North America, which started in 1995 in Sherbrooke, Quebec, and then later on in 2000 in the US. One of the work that I'm really very proud of is our research on understanding the rheology of pumping. As you know, pumping is the fastest way of delivering concrete, and we've conducted quite a bit of work on that, introduced some analytical models, design tools, testing procedures, and they were put in applications in one of the longest pumping projects in the world, which was actually in Algeria about 10 years ago, 3.4 kilometer tunnel. But also in between 2006 and 2009, the world record for pumping, and that was in Burj Khalifa in Dubai, in the UAE, where 611 vertical meters was pumped single stage. And a lot of the research that we introduced on pumping, understanding the pumping, was implemented there, and I was associated in both of these two projects as consultant.
Oh, this is quite incredible, quite remarkable. We look into this technology of self-leveling materials, self-compacting materials, self-consolidated materials. I really see a lot of possibilities in our country. Do you know something equivalent that's been done here in Brazil? Or in other words, do you see good perspective for self-consolidated material, high, long distance pumping? Because we look to our coast, we are now doing many construction, very high buildings that are being pumped. How do you see this kind of technology being applied in our country here? It's like a continental country like USA. Is it okay? Do you think it's possible?
Yeah, I think a lot of, I mean, since I was in college, I've been associated with a lot of the innovations from the cement and concrete industry in Brazil. In Brazil, some of the biggest hydroelectric dams were constructed, and a lot of innovations in the use of high-strength concrete in tower buildings. I know Professor Paulo Helene has been a pioneer in this field and a good friend of mine. So, you know, there's quite a bit of technology and innovation already in the country. You have a very big and prosperous cement industry that is an admixture industry, and construction company and leading architectural companies and design offices. But I think it's always a matter of trying to realize the innovative aspects and how one can use it in their design and construction to improve environmental conditions, enhance efficiency and productivity on the job site. And also we should remember more and more the environmental impact of what we do as engineers is very, very important. A technology like SCC can solve a lot of the problems. We mentioned some of them in pumping, but also in the precast industry, more and more construction is going to go prefabrication, including, hopefully in the future, more of it would be digital prefabrication. But in the prefabricated industry, SCC has penetrated the market on the order of 70% plus in Europe, and at least 50% in North America. Whereas the cast in place is a little bit more difficult, lagging quite behind, because there are many changes of materials, and the contractor is not the same as the material supplier. But in the precast industry, I could see a lot of use of this technology and with the technical know-how that you already have in the country, I see a lot of future for a material like this to improve productivity.
Oh, this is incredible. Connecting this discussion with environmental aspect, as you told, all this kind of pumpable concrete, self-compacting concrete, they normally have a larger amount of paste of fine particles in the system to get this behavior. And we are facing times where CO2 is a discussion very relevant for the community. How to go to this direction without increasing the CO2 emissions or the environmental impact? What's the
Yeah.
future of sustainability in concrete for you?
Well, I mean, concrete is the most used man-made material in the world. There's no way around concrete. In terms of material, it's the second used material in the world or consumed material after water. We consume a lot of concrete, and we cannot see anything that can be constructed in economically in using locally available materials and shape it to the form and the characteristics that we, design it for. But the cement part of the concrete, as you know, is emits a lot of CO2, and there have been many roadways and roadmaps to reducing CO2 and the impact of cement on the greenhouse emission. But we could definitely design the concrete to be more sustainable. It's already green, but we can make it greener by reducing the CO2 and the energy consumption per cubic meter of concrete. We have to think of cubic meter and not of ton of materials. For example, you can reduce the size of your structural elements by using high-strength concrete, where you can reduce the emissions quite a bit, even if you are using concrete mixtures that have more cement. You can use chemical admixtures to allow you to reduce cement content. You can use supplementary cementitious materials and waste products to replace part of the cement, i.e. replace the clinker factor. There are many ways of enhancing the sustainability of the concrete industry.
Oh, it is quite challenging, and I agree with you. Well, I think the future will be with more, how can I say, engineered concrete, if you can say this. Another aspect that you told about the precast is like a digital construction or all these modern techniques that are around of digital manufacturing. How do you see the future of these technologies for the world? And if you think that we will achieve all the countries, including Brazil and any other developed countries, since you need large scale, you need to fast in the production of and increase the productivity. And how digital will you go with this new era of concrete? What's your view for that?
Yeah, I think these are very, very exciting times for the concrete industry to try to embrace new technologies. I was reading recently a report that was published actually in 2008 by the U.S. National Academy of Engineers. And this is a very high-level thinking tank that provides a recommendation of policies to be adopted by the U.S. administration. And they had 14 recommendations, but one of them was the rehabilitation of the urban infrastructure. And big urban areas, like you have a lot of them in Brazil, including Sao Paulo, where you are, they are saying that you have to reconstruct and rehabilitate using innovative materials, using sensors, and automation in construction. So the word automation is very important in fabrication manufacturing, and we in the construction industry are quite behind. We use quite a bit of automation in shotcreting using robots, especially in difficult conditions like in tunnels. But we do not take advantage of this very interesting technology in everyday construction. So about 10 years ago, digital fabrication started, mainly at University of Southern California here in the US, but also in Europe at some leading institutes such as in Zurich and at Dresden in Germany and China also. But a lot of very interesting research and some field implementation is going on in this field where you are combining the technology of robotics with the technology of sensors and AI, and the technology that we are well familiar with as concrete scientists and engineers, and that is control of cement hydration and control of pumping and extrusion, i.e. rheology, to bring all these technologies together to produce something that can work 24/7, very repetitive motions. We are really at the infancy of this technology, but it's a very fast-growing technology. And if you're trying to keep up with the publications and the field implementations, this reminds me of the early 2000s when somebody was trying to chase the SCC technology, and every year there's about 1,000 publications taking place in this field. It's a very growing field, and I think there's still a lot of time to go with that, movement and then take advantage of it. So it's very exciting for us as engineers.
Yeah, we are. I think we are living, how can I say, a game changer era. And for you, you participate of the previous one, SCC, one of the fathers. So it's an honor to be in contact with you. And just to conclude, I'd like to you, if you could send some inspiring message to professionals that are part of this Hubik chair that we are starting in Brazil. And how do you see this kind of initiative in our country?
Yeah, so no, this is actually very, very exciting. I'd like to thank all the partners that have participated in this industrial chair and the leadership of the Brazilian Portland Cement Association and the people at the University of Sao Paulo for leading this. This is really an exciting journey that the industry is embarking on. When I was in Canada, I had the pleasure to work with 17 industrial partners through a 5-year program that is funded by the federal government and also by the industrial partners, which came from public and private sectors, including material suppliers, contractors, testing labs, design professional, admixtures, cements, manufacturers. But the program was meant to promote high-performance concrete with adapted rheology. But whatever the program is, when you are working together like you are, that every part of the value chain that is collaborating together, you're going to be able to introduce technologies much faster to the marketplace, because everybody is going to be putting their inputs, trying to identify some of the challenges for the researchers to work on, for the industry to collaborate to solving those problems. And I've read some statistics that when you are trying to introduce a technology in civil engineering, again, civil engineering is a very, very conservative professional because of the public safety that we have to deal with. But when you are trying to introduce something from basic research to being implemented after the codes and everything, it takes on the average 17 years. And I think working together with this Hubik chair in Brazil, I think you can reduce that tremendously. Hopefully only 4 or 5 years between introducing something and taking it all the way to implementation. So it's this very exciting time. I think there's a lot of challenges, but also a lot of opportunities ahead. And I'm really very, very glad to be part of it.
Kamal, it's a pleasure. Thank you very much. I think this was very good, very excellent answers. Now,